Hello everyone, and welcome to another remote sensing lecture video. And in this video, I want to wrap up our discussion on satellites as remote sensing platforms by talking about the advantages of using satellites, the disadvantages of using satellites, and some examples of how much these images actually cost to acquire for use. And what I want to do first is I want to talk about sort of circle back to this idea of sun synchronous versus geosynchronous, and why one of these is far more useful to remote sensing than the other. And it has to do with this diagram that we drew last time. All right, so if we were to have a remote sensor attached to a geosynchronous satellite, right, if this blue option, right, that never moves relative to the Earth, if this was our remote sensor and it was taking pictures, right, gathering imagery, if you think about it, right, let's just, for simplicity's sake, say that each one of these time steps was a single image, and there's no imagery being collected in between. That's a very simple example, but it proves the point. Right? If we had 5 images, if the satellite was geosynchronous, right, then all 5 images would be the exact same place on Earth's surface. Versus if the sensor were attached to the sun synchronous satellite, right, we would have 4 images of different places, and then a 5th image, which would be new data for the place at time 1. So, put another way, right, if we wanted information from this part here using the geosynchronous type of satellite, we would have to then launch a second satellite and position it so that it was relative to this place. Okay, so I just want to let that sink in. With geosynchronous satellites, if we want imagery of a place on Earth, we have to make a new satellite for every area that we want. Versus sun synchronous, right? We launch one satellite, and we're at whatever orbit it's in is going to determine how often it goes around, right? But with sun synchronous, we're able to get imagery of the entire world, right, at some time frequency. And if we launch more satellites, we get that time frequency becomes greater. But you can hopefully get from this diagram and what I just said that sun synchronous, right, sun synchronous is much more common in remote sensing. Right? Why? Well, again, you get the entire, or most of, depending on the satellite, or you get the entire Earth with one satellite, right? And that goes back to this diagram, right? The red satellite, which is sun synchronous, right? With this one satellite, we got imagery of the entire Earth with some time frequency. Versus geosynchronous, right? No matter what time it was, we only ever got one place on Earth's surface. Hopefully that makes sense. So let's go ahead and let's now talk about the pros and the cons. Right, pros and cons. Okay. The first big pro of a satellite is that once it's launched, my handwriting got really bad there, sorry. Right, once it's launched, you get global coverage. Right, we saw that with the sun synchronous satellite. So once you put it up, once you launch the satellite, you get global coverage. It doesn't cost you any more money. Right, once you put it up, you get global coverage. 2, right, because the satellite is orbiting around the Earth, you get constant. I shouldn't say constant. You get consistent revisit times. Right, you get consistent revisit times, and that's that temporal resolution, right? Temporal resolution. Right, that satellite is orbiting the Earth, and at some time frequency, you're going to get repeated images of the same place. So if we take Landsat, which is my favorite cherry-picked example, right? If we take Landsat, you know that you are going to get an image of the same spot on the Earth's surface every 14 days without having to launch any more satellites, without having to pay anybody any extra money, without having to do anything else, right? You're going to get imagery every 14 days of the same place on the Earth's surface. And that is extremely useful from the perspective of if you wanted to take the wildfires in California, for example. Right, if we wanted to examine how those wildfires change over time, right, having this consistent revisit time, right, every 14 days we can see how has the fire changed, how has the fire changed, how has the fire changed, right? All without having to spend any extra money from a collection perspective, right? You have to spend money to get the Landsat, you don't have to. But right, with satellite imagery, you don't have to expend any extra effort to get this consistent revisit time, which you would have to with planes and drones. 3, and this kind of goes along with this, is you have and I'm going to put this in all caps, vast image archive. Okay, and what I mean when I say image archive, right, you can think about this kind of like your Facebook feed or your Facebook wall, right? If you took a picture of a selfie in 2012, right, that's an archive. That is you back in 2012, right? With satellites, right, some of these satellites have been in orbit since the early 2000s. Some have been in orbit since the 90s. Landsat's been in orbit in one form or another since the 70s, right? Again, with this constant revisit time. So we have satellite imagery for Landsat, for example, right? We have imagery every 14 days of the entire Earth's surface going back all the way to the 1970s. Right? We have an extremely vast image archive that we can go back and compare things to, right? We can look and say, okay, how has Las Vegas, for example, right? How has Las Vegas expanded over time, right? We can do that with satellite imagery because we have this vast image archive. Okay, so hopefully that makes sense, right? You get global coverage, you get consistent revisit times, and because these two things combine and they've been around for a while, you have an extremely vast image archive. Finally, let's talk about some cons. And the one that I want to talk about most, well, there's two. But the one that I want to talk about the most is a lack of flexibility. Right, a lack of flexibility. What do I mean by that? Right, so you have to sort of imagine the world we live in right now. Technology is constantly improving, right? And if I build a satellite and I put a sensor on that satellite and I launch it into space, and then 2 weeks later, Elon Musk comes out and says, I have a revolutionary sensor that's going to change remote sensing forever. it would be virtually impossible for me to go up to that satellite and install this new sensor. So in that regard, right, once I put it into space, I can't change anything. So if technology improves or something changes or if something breaks, which does happen from time to time, right, that satellite imagery, you just have to deal with it, right? You can't improve it, you can't fix it, you can't change it. So that's the lack of flexibility. The other part of that is this idea of consistent revisit times. Right? Once I launch a satellite, it's in orbit. It's going to orbit at the same. It's going to basically orbit at the same speed, with some variation. So with Landsat again, as an example, right? I'm going to get imagery every 14 days from Landsat. That means I'm going to get imagery every 14 days from Landsat. That means I can't get imagery every 7. I can't get imagery every 21. I'm going to get imagery every 14 days. And if I want to change that, right, if I want to get imagery more frequently, I then have to invest money in an entire second satellite and launch it into orbit and go through all of that hassle so that I can get imagery more frequently. And when we talk about some of these constellations, that's exactly what they've done. They've said it's worth our money to invest in multiple satellites so that we can get imagery acquired faster. But in terms of a single satellite sensor, right, you can't change what it collects. If it breaks, you're screwed. And you can't speed it up or slow it down in terms of how often you get imagery. So hopefully that makes sense. Hopefully the pros and cons, I think they're pretty logical. If any of this doesn't make sense, I encourage you to pause the video, go back, rewatch the parts you're confused about, and as always, please reach out. Thank you.